Tonight on Nova, what is lurking in the sands of the Gobi Desert? Is it Velociraptor, the villain of Jurassic Park?
Mark, Mike here.
Yeah.
I found a monster.
Sandstorms, flooded roads, and searing heat won't keep these scientists from finding the perfect specimen. This may be the world's greatest dinosaur graveyard. The hunt is on for Dinosaurs of the Gobi.
Funding for NOVA's 20th anniversary season is made possible by Lockheed, America's aerospace company, supporting math, science, and engineering education for national technology leadership. And Johnson & Johnson, the signature recognized around the world for commitment to quality healthcare products for the entire family. Major funding for NOVA is provided by the Corporation for Public Broadcasting and by annual financial support from viewers like you. The fossils of the Gobi Desert are legendary. They reveal in remarkable still life creatures from the age of the dinosaurs. Here, fierce velociraptors once stalked their prey, and protoceratops nested. Nowhere else are dinosaur remains so richly preserved and so sought after.
I'm looking for fossil bone chips here on the ground. The idea is that there's maybe a specimen nearby that has broken up into pieces. Here's one here.
Well, it's mainly being able to tell the difference between fossil and a rock.
Now your mind wanders, that thinks about things totally unrelated to paleontology or about other things in paleontology. But immediately when you find something, you do start to concentrate.
Most people think of us as dinosaur hunters. And that's true, but it's only partly true. These rocks entomb a lot of different bones that represent an animal community that lived some 80 million years ago.
For over half a century, communist isolation kept Western scientists from exploring this vast dinosaur graveyard. Now they've been invited back. This team from the American Museum of Natural History will spend 3 grueling months in the fossil fields of Central Asia. They've shipped to Mongolia food, equipment, and even jeeps.
We've got all 8 of our vehicles, I think. I haven't seen the tank truck yet. We've got all our gasoline. We've got all our drivers. We've got our cook.
Got enough beer, Jim?
I think we do at least for a day.
Jesus. I thought I was going to lose weight on this trip.
Well, I can't find my cap at the moment. I'm trying to locate the damn thing so I don't get too sunburned.
We've got the crew, and we've got almost everything but one missing hat, I believe. So we're ready to roll.
The team follows in the tracks of the celebrated expeditions launched by the American Museum in the 1920s. These earlier explorers hoped to find the origins of human beings in Central Asia. Instead, they found a treasure trove from the final reign of the dinosaurs. The romantic tales and fossils they brought back inspired a new generation of paleontologists. And their leader, Roy Chapman Andrews, may be the real-life model for Indiana Jones. Then, as now, the Gobi was a forbidding place of scorching sand and winding caravan routes, but it held an irresistible bounty. More than just fossil hunters, paleontologists pieced together the history of life on Earth. These explorers of the Gobi seek answers to some of evolution's greatest riddles.
I'm interested in fossil mammals and looking at the rise of the mammals with the demise of the dinosaurs.
I'm here because I want to find some of the small carnivorous dinosaurs that are closely related to birds.
Mammals are the ones that mostly interest me, I confess. We all collect whatever there is to be collected.
I consider myself to be a kind of a dedicated amateur. I'm here for the love of it.
Very keen on finding some important fossils, fossil crocodiles there.
What particularly fascinates me as a geologist is the rocks, and how do all those relate to one another in terms of time?
The Mongolian Academy of Sciences has invited this group from the American Museum to work with them for a series of summers in the Gobi. The team made a field trip in 1991 to scout out locations. Now in '92, they've mounted a full-scale expedition. The months ahead promise exciting finds and a few unpredictable turns.
What's gone wrong, Mike? This truck busted its differential.
Yeah.
And so the older driver's going back into Ulaanbaatar for a couple days to get it fixed. And then he'll be joining us at Flaming Cliffs, I hope.
Demberilin Darsheveg is one of the outstanding scientists in Mongolia. He's worked in the Gobi for 30 years, and his knowledge of its terrain and fossils will be critical to the team's efforts.
The gas truck's broken. We're sending it back to Ulaanbaatar, hopefully to meet us somewhere down the road. Right now we're going to drive out about 150 yards to make camp, and then we're going to pour off gas into all the barrels we have. So, we'll see.
In this unmarked landscape, a special computer guides the way.
We're heading 160 now, and we need to go 186.
It plots location from satellite signals.
I think that keeping detailed road logs of wherever we have gone in these expeditions is important record keeping for future fieldwork by the American Museum or other American paleontologists.
First, they head south to a place the Andrews expedition visited 60 years ago. Andrews wrote of a majestic canyon that seemed to shoot out tongues of fire in the evening light. He named this place the Flaming Cliffs. Its red sandstone walls were studded with white fossil bones. This labyrinth of ravines and gorges revealed beautifully preserved skeletons of late dinosaurs and early mammals. But the greatest discovery of all was a nest of dinosaur eggs, the first ever seen. The find was so astounding that initially Andrews' team refused to believe it, thinking the eggs were probably those of an extinct bird. But they were elongated with rough surfaces like the eggs of modern lizards, and the nests were surrounded by the fossils of a primitive horned dinosaur. Andrews' team concluded this must be the nest of a protoceratops. You can still find dinosaur nests at the Flaming Cliffs if you know where to look, and Darsheveg knows.
What we've got is about 9 eggs in a dinosaur nest that's eroding out of this hillside here.
Well, it's always worthwhile looking at eggs, trying to find out whether or not there are embryos in the eggs, because these baby dinosaurs give us clues to dinosaur growth and development that we can't get very often.
As nests go, this one's pretty good, because it's a lot like a lot of the ones from the Central Asiatic expeditions of the 20s, in that The narrow end of the egg faces the outside of the nest, and the wide end of the egg faces the center of the nest, and the eggs are all laying in a large circle like this. It's kind of interesting because it's one of the things about dinosaur behavior which is rarely obtainable from fossils. They just didn't go out and lay their eggs wherever and just cover them up, which seems to suggest that there was some complex sociobiology to nest building in dinosaurs, just like there is in birds today.
There's evidence in the nests of other dinosaurs that parents stayed with their hatchlings to nurture and protect them. 80 million years ago, this area supported a diverse range of life. In addition to dinosaurs, turtles, crocodiles, and small shrew-like mammals all left fossils behind.
These beds are excellent for preserving fossils because they consist of sand dune fields that were moving along and engulfing whatever carcasses might be in front of the sand dunes. The dinosaur nests are a good example. They were simply covered too deeply. The rocks are able to produce new fossils all the time because as the old ones get destroyed, new ones are emerging from the rock as the rock is removed by wind and rain.
We're interested in everything that lived here. The small lizards, the mammals, the dinosaurs, everything.
Fossil hunting means endless hours pacing and prospecting, scanning the ground for the bright glint of tooth enamel or fossil bone. What appears a simple rock to some is a treasure to the experienced eye.
It's a dinosaur skull. The nose is right here. There's a long frill at the back of the skull. The eye is here, the lower jaw. It's a specimen of Protoceratops.
This dinosaur was first discovered by Andrews' team in the 1920s. They named it Protoceratops andrewsi, Andrews' first horned face.
In the summer of 1923, the Americans were collecting here looking for dinosaur eggs. But one of the small nodules that was found had a little skull in it, and no one knew exactly what it was, but it was taken to New York and prepared, and a cable came back to Beijing saying, my God, it's a mammal.
It was a fragment of the rodent-like Zalandolestes.
Those fossil mammals are tiny creatures. They're about as large as a shrew, a living shrew or a tiny mouse today. But they're very important because these ancient mammals from Mongolia preserve very important clues that tell us something about the roots of mammalian history.
These beds are rich with the fossils of mammals and dinosaurs and other animals of the late Cretaceous. This period, ending 65 million years ago, was the last age of the dinosaurs.
At the end of the Cretaceous, we have the famous dinosaur extinction event. And very nearly around the same time, we see a great flourish and diversification of all the mammalian lineages. So those small furry creatures who ran around during the Cretaceous period really take off and diversify. So we have this really dramatic shift over from a dinosaur-dominated to mammal-dominated faunas.
Many scientists theorize that what finally killed off the dinosaurs was an asteroid that fell to Earth, sending up an enormous cloud of dust and debris. What remains a mystery is how small mammals survived.
We're very interested in what's happening as we enter the age of mammals. And there are only a few places in the world where we can pick this information up. We're all asking the same question, namely, how did life evolve and diversify? And we can make a map of these changes. There are millions of species on the planet, but all these forms of life were organized into groups. They form one gigantic branching tree. If we look at mammals, we have placental mammals, which includes the humans, then the pouched marsupials, the kangaroos and their relatives, and then the egg-laying monotremes, the duck-billed platypus and the echidna. Now, all these groups seem to be very different, but they're all part of one major branch. Why? Because they share key characteristics found in their common ancestor. All mammals have the ability to provide nutritive milk for the young. All mammals also have 3 tiny bones in the middle ear for specialized hearing. As we move up the evolutionary tree to the common ancestor of the marsupials and the placentals, the egg-laying habit for reproduction is lost, and instead a specialized mode of reproduction allows live bearing of the young.
Scientists learn how different creatures evolved by comparing their physical traits and tracing their origins back through time. Mammals descended from an ancient line whose members all have a liquid egg sac. From that same ancestral line came a group including turtles, characterized by an opening in the roof of the mouth. Later to branch off were lizards and then crocodiles. Fossil evidence shows a common lineage leading to dinosaurs and their likely descendants, birds. This process of mapping relationships is called cladistics. Evolutionary biologists are particularly interested in where the branches split.
We really want to know what happened in evolution that allowed the emergence of these new kinds of organisms. To us, fossils are part of the whole scope of life. They may be animals frozen in a particular time, but very often can give us more clues on the dynamics and change of life, the evolution of life, than a living creature, because they preserve the characters that are so important for mapping out the pathway from the past to the present. Oh, no, we can't do this. Michael, not after this.
After Andrews explored the Flaming Cliffs, Westerners were closed out, but Russian, Polish, and Mongolian expeditions have thoroughly combed this area.
I think that the Flaming Cliffs is basically not the place to look for great discovery anymore, because it's not a very large area, and there isn't much left.
Where do you want it, Mark?
The plan is to move out west to places Dasheveg knows where Andrews never went.
Last year, we found a very important velociraptor specimen in this area, a skull that we have every reason to believe was attached to an entire skeleton. We collected the skull. It's back in New York. We'd like to see if we can find the skeleton.
Velociraptors, infamous as the villains of Jurassic Park, are actually from the Cretaceous period. A large brain made this dinosaur a cunning predator. Velociraptor means swift robber. As hunters, they were well equipped with grasping hands, strong hind limbs for jumping, sickle claws, and razor-sharp teeth. Velociraptors belong to a group called dromaeosaurs, and dromaeosaur fossils are very rare.
We took some photographs of the site last year from exactly the place where we collected the specimen, so we could find it again this year. But right now we're having a little bit of difficulty finding the place again and matching the photographs up with the horizon. Mark calling Mike. It's not there.
I'm trying to find some fossil mammals. I've had a tough day. I've been out here for about 6 or 7 hours. It's pushing 100 degrees Fahrenheit. And I'd like to find one. So, they're not very common. Just the same. One a day would be nice. They occur in these concretions, these hard sandstone nodules. I found all the protoceratops you could ever want. There are 11 skeletons right on this hillside. But I'm not interested in those. If you were in North America, these 11 protoceratops skeletons in this small area would be a spectacular find. Just that we're really interested in the goodies, the mammals and the velociraptor and other things. And those are rarer. There's really nothing wrong with protoceratops, but they're so common here. We call them Cretaceous sheep.
I call them the sheep of the Mesozoic. That I think that they're pretty analogous to that they were what everybody ate.
At day's end, the prospectors return, exhausted but successful.
Found it.
Found the dromaeosaur site.
Found the dromaeosaur.
Good.
Malcolm got 2 really nice lizards, skeletons.
And a Domosaurus and one other Tiid. I haven't seen Mike's yet.
It's great.
Good
Not
day,
a bad
all in
day,
all.
really.
Well, I found one vertebrae on the surface that I have in my pocket. Doesn't look like much, but it's a dromaeosaur velociraptor type vertebra.
We're going to prospect that whole slope, and I think it's worthwhile. We may get a mammal skull if we look diligently enough.
3 skulls in one day, though, that's still pretty good.
Yeah.
Like I was saying before, 1 specimen a day and we're happy. So.
Yeah, no, this was pretty good.
Great.
They're all really nice specimens.
So what you gonna do now?
Have a beer.
Nice tepid one.
Today is the 2nd day of Nadam, their national holiday. And so today they've been listening on the radio all the day long. See, Marky, here's the skull. There's a tail coming out.
It's part of a group of lizards called polyglophanodontid that are just known from the Cretaceous of Mongolia and North America. And they have large acorn-shaped teeth in the tooth row.
And at first I was a little even more thrilled because I thought I had a mammal from a distance there. But I think a lizard is just fine.
The holiday brings together nomads from scattered parts of this vast and desolate land. Through long months in the desert, the team takes comfort in pastimes reminiscent of home.
It's similar to working in the American West. Having campfires, you're barbecuing, you're drinking, you're having a good time, and you're talking about science. Except in the American West, you don't see camels walking around.
With the velociraptor located, what remains to be seen is how 80 million years have weathered the skeleton.
How's progress?
It's going pretty well, but we have probably about 2/3 of the skeleton exposed now, starting up here near the head and going farther back in the body. And here we have a right front limb, and we think part of the left front limb. Back here we have all of the individual vertebrae and some ribs. It's still extending farther back into the hill, so we're pretty hopeful that most of the skeleton will be there.
If the tail is there, it might take another day or so.
Even in Andrew's day, excavating was not just a matter of digging out fossils, but of understanding their place in time. While Jim and Mark dig, geologist Lowell Dingus plots the location of the fossil in the geological record.
One of the more important things we need to do when we find a fossil is to record not only its geographic position, but also where it is in the sequence of rocks, because fossils that are found lower in the sequence are older and died before fossils that are found up higher in the sequence. I can level my eyesight right through to this little ridge of rock that we're walking up, and I know how high my eye level is, so it just gives me a measurement, an accurate measurement, which if I piece together like this, just adding up the eye levels as I go, then I know how high the velociraptor is in the sequence.
Recovering a well-preserved velociraptor could help answer an intriguing question. How are dinosaurs related to birds?
One real interesting thing would be to see if we can find a wishbone. In birds, the wishbone is formed of the clavicles, your collarbones, that fuse together along the midline and form somewhat a sort of spring used in flight. The condition of the clavicles has never been described in Velociraptor or any dromaeosaur for that matter, which are thought to be the most closely related to birds.
It's still debated whether birds evolved directly from dinosaurs or from a more distant reptilian ancestor. Mark wants to show that dromaeosaurs, like Velociraptor, share traits with early birds.
One always thinks about the specimen that they'd love to find. Usually it's some spectacular specimen, but I think for the research that I'm doing now and everything, what I would like to find the most would be a well-preserved bird, a true bird, not one of these bird-like theropods, but a bird that was clearly referable to one of the modern groups of birds. Would be a tremendous discovery out here.
Such moments of great discovery, though, are rare. These are months of tedious and often lonesome work in the desert.
Do you think about dromaeosaurs in the shower?
No. Think about home. And, yeah, home mostly.
Home for the team is New York, where the world's greatest dinosaur collection is found at the American Museum of Natural History.
The relationship between birds and dinosaurs is really pretty obvious if you look at the skeleton. Both have these large brains, very large eyes, and air sacs on either side of the skull, as well as a very S-shaped curved neck and several other features of the arms and legs. This is the foot of the dromaeosaur. The number of bones in each of the toes is identical in this harpy eagle right here. This is a dromaeosaur wrist. The bird wrist has this large, crescentic, what we call semi-lunar carpal, which is identical to the one in dromaeosaurs. In fact, the evidence is so pervasive that about the only thing wrong with this hypothesis that you may suggest is that birds appear much earlier in the fossil record than do the dinosaurs, which they're supposedly closely related from.
The dinosaurs most similar to birds were some of the fiercest predators of their time. Like birds, they may have been warm-blooded and in constant search of prey. Swift runners and agile. But how could birds descend from creatures which appear millions of years later in the fossil record? This chart shows fossil finds.
This is now the end of the Cretaceous, when the typical dinosaurs disappeared 65 million years ago. This is the beginning of the Cretaceous, the end of the Jurassic 135 million years ago, and this is the Triassic. Birds first appear in the early Cretaceous and have survived to the present. The proto-bird Archaeopteryx first appears in the late Jurassic. Dromaeosaurs, things like Velociraptor, first appear in the Middle Cretaceous and survives till the end. Troodontids and oviraptors also appear in the Late Cretaceous. And Ornitholestes appears in the Late Jurassic.
Fossils for birds date back earlier than the fossils of their supposed forebears.
How can birds be derived from these small advanced carnivorous dinosaurs? But I think using cladistic analysis, we can reevaluate this problem.
Cladistics help date the emergence of animals on the tree of life. Birds now and their early ancestors have a trait in common with dromaeosaurs like Velociraptor. All have a pubic bone that points backwards, placing them on the same evolutionary line. They share more primitive features with troodontids, indicating this dinosaur emerged earlier. Traits of other related dinosaurs place them still further back in time.
So now we have dromaeosaurs going back to the Late Jurassic. And the same with the troodontids and oviraptors. Ornitholestes already is just where we would predict it to be. Just because the fossils haven't been found doesn't mean that the things didn't exist. I call these things ghost lineages or ghosts. What it does is it extends the history of these organisms, sometimes 2 or 3 times as long as they're indicated from in the fossil record. In fact, birds and Archaeopteryx can be related to dromaeosaurs and troodons, even though the fossil record doesn't seem to suggest so.
I think that the notion that dinosaurs went extinct is, within the scientific community, is pretty much been demolished, that birds are dinosaurs. And in fact, if one were to take a very hardline view of just the data that's out there, one could even argue the point quite successfully that dinosaurs today are more diverse than they've ever been.
Conditions in the Gobi, where winds can gust up to 100 miles an hour, lead the team to take special precautions.
We're putting glue on the specimen to harden it. We have several thousand kilometers to go this summer over really bad roads, and we're a bit worried about the specimen falling apart inside the jacket while we're traveling. So we're trying to harden it as much as possible before we put the jacket on.
A gauze and plaster cast will protect the Velociraptor on its journey home.
Is the tail there?
No, the tail wasn't there. But while we were waiting for the plaster to dry, we did find another one, which looks like it will be even better, so tomorrow's work.
Priscilla, what on earth are you doing?
I'm cleaning the mold off the jerky. Jerky is dried beef. Unfortunately, it got moldy coming across the Pacific Ocean.
Small Protoceratops. Do you have a locality number for that, Mark?
Not a locality number, I'm just calling it Chimney Dude.
Okay.
But you do have the satellite
Yeah, the
coordinates.
satellite coordinates written in that.
Mark, this is the multi-skull found on 7/15/92.
7?
Yeah, you wrote it on the label.
Nearing the end of their stay at this site,
Okay,
the
here's-
team carefully catalogs their finds.
Mammal. Well, yep. You
The
sure
princess
it's in
and
here?
the pea.
There it is.
Tiny but interesting. Here's the multi-skull. There's the lower jaw, and you can see a little row of teeth. It's not perfect, but it'll look a lot better when it gets through the lab back at the museum. At least we got a few mammals here, and this is one of our prizes. One of, I think, 3 or 4. So we did pretty well, since they're pretty rare.
This is a really nice Velociraptor skull, part of one at least, that I got out in a wash west of here. Here it is. You can see the fangs here going along. This is the upper jaw. It's really exciting to find something like this.
The true importance of new fossils can sometimes go undetected in the field. Back at the museum, specialists meticulously prepared the velociraptor. Mark had hoped to find a wishbone to help prove this dinosaur's link to birds. But the key piece in the puzzle of bird evolution was found not in a velociraptor, but in an altogether different fossil.
We didn't find a wishbone, but we did find something pretty great. We found an early bird, which is more closely related to living birds than Archaeopteryx is to living birds.
Archaeopteryx, or ancient wing, was the first fossil linking dinosaurs to modern birds. It had a long, bony dinosaur tail and sharp reptilian teeth, yet its feathers were clearly bird-like, casting Archaeopteryx as a transitional figure. Now new evidence supports the theory that birds evolved from dinosaurs. This fragment, found several years ago by the Mongolian scientist Perlet, hinted at an unknown early bird. Then the 1992 team recovered an almost complete skeleton. This strange new creature, like an ostrich or emu, didn't fly. Instead of wings, the front limbs are stubs with a single claw, earning it the name Mononychus, one claw. Its leg bones, breast, and brain case all link it more closely to modern birds than even Archaeopteryx. Yet it still retains many dinosaur traits. Mononychus seems to be further proof of the dinosaur-bird connection. But was this truly a new find?
One of our collection assistants found in the collection this specimen right here, which is labeled simply bird-like dinosaur from the 1923 expedition to the Flaming Cliffs. And in fact, the Andrews expedition collected one of these guys, and it just remained undiscovered for about 70 years.
Out in the field, the team is having more pressing difficulties. With the tanker fixed and their haul securely packed, the scientists are ready to venture into less charted hunting grounds.
The expedition.
The team will head deep into the southwest, into even richer territory, to Dasheveg's favorite country at a place called Naran Bulak. But getting there will be no simple task. They first must find a pass through an 8,000-foot mountain range.
Nice piece of cake, as long as it doesn't rain.
Tanker's in pretty bad shape right now. We've done some major surgery on it, the Mongolian mechanics, and I hope that we'll get it going again. They're fairly ingenious guys. I mean, this morning they made a gasket out of a cereal box top.
The tanker is working again. For a while.
I think I see a road up there, but I'm not sure. Worth a try, okay. Is this the same wash that we went up before?
Pretty sure.
Charting their direction is not the problem. It's finding a road through the mountains.
We're lost. We are lost. We do not know the correct way to cross this gigantic range of mountains. We think now that the road is about 5 or 6 kilometers west of here.
Well, we were not lost in terms of where we were. What we were having problem with, though, is finding a road.
We will probably not get to Naran Balak tonight as planned.
Ruptured gas tank.
Stop.
Yeah.
What's the plan, Mark? We're gonna try to get this plate off the top and then put something down in the bottom that'll work like a bathtub stopper.
It's supposed to be for firewood.
Jim, are they using the inner tube?
Kind of look like a swimming pool in Las Vegas. Feels like paradise here in Naran Balak. We finally made it after this horrendous trip. It's great to be here.
They've settled in the middle of prime fossil territory, and each team member has special hopes. Dasheveg wants to prospect right here. Malcolm and Priscilla will look for fossil mammals on the other side of the valley. Naran Balak will serve as the team's base camp for the rest of the summer. For hundreds of years, dome-shaped tents called gurs have provided shelter to nomads of the Gobi. These traditional homes of wood and animal skin rival any modern camping gear.
Great. Home sweet home. Sambanu.
Dasheveg and his colleagues in Mongolia have worked in isolation and with few resources in past decades. Yet they've kept paleontology alive in the Gobi. The fossils unearthed in these fields now can be compared with those of North America, yielding new insights into the past. From their base camp, Mark, Jim, Lowell, and Mike venture to more obscure parts of the desert. This trip is to the region of Hulsan. Jim is a specialist in the evolution of crocodiles.
I'd like to get one of these crocodilians called Shamosuchus, which is very closely related to the modern crocodilians. And because it's closely related, it provides a lot of evidence about the primitive or ancestral condition for the modern crocodilians. So what I'd really like to find would be a nice skull and skeleton laid out in the rocks. But we haven't had too much success with crocodilians as yet.
Mark, Mike here.
Yeah.
I found a monster.
What kind?
I don't know. I think there are 3 or 4 vertebrae, nicely preserved, a little chunky on top, but in good condition, curled up, maybe 4 or 5 feet long.
Great, really big?
Looks like a big guy.
It looked like we had a nice specimen here. There are 4 vertebrae weathering out, but unfortunately, we don't seem to have much more of it. So, we really don't have the prize that I thought we had when I first saw it. Yeah, well, you know, it was exciting for a moment.
Well, I didn't find a crocodile, but I did find this nice lizard skull. In fact, we're thinking it might even be a new species. Once we get it cleaned up, we'll know. I returned to one of my favorite spots, a spot which last year, while I was relieving myself on the other side of camp, I found a beautiful lizard skull and a beautiful mammal skull. So I returned to what I call my piss spot, and lo and behold, it yielded more treasures, including this beautiful little mammal jaw. Well, in fact, we lucked into quite a little treasure trove of crocodiles once we reached the locality of Zos on our way out. I haven't had a chance to actually study these, and also it will take some time to clean up these fossils. But our preliminary look at them is that they're very similar to Chamosuchus, which is exactly the kind of animal that I wanted to find.
So Jim got his crocodiles, and Mark got his velociraptor and his bird. For Mike and Malcolm, the Gobi turned out to be a gold mine for mammals.
We've known about Cretaceous mammals for a long time in Europe and in America, but until now we've had to make do with bits and pieces, tiny little teeth like this. We haven't had skulls, but in Mongolia there are superb specimens, excellent skulls and partial skeletons. In just a couple of afternoons at Naran Balak, Priscilla and I found up to 50 specimens.
Relationships between mammals have always been worked out using tooth structure. But with the Gobi discoveries, scientists can now look into other aspects of anatomy, particularly the skull. And the team brought back a superb specimen of the shrew-like mammal Zalamdalestes.
If you look at the beautiful fossil skull we found of Zalamdalestes, there is a pathway of major vessels that come into the skull and supply the brain. They cut across along the neck and cut across the base of the skull. Now, these vessels aren't preserved, of course, in the fossil, but the troughs and holes in the skull indicate their pathway. We've taken this skull and put it under probably the world's most powerful CAT scan to actually look inside the brain case of this 80-million-year-old animal and track the pathway of the blood supply to the brain. At various times you can see the teeth coming out of the jaw as we move from the front of the skull to the back. We can see the eye sockets and parts of the lower jaw. And you can see the roof of the skull coming out nicely. And there we have the base of the skull. Right there, Tim, yeah. You can see the canals, and those canals are carrying blood vessels forward. And here you can see the openings at the base of the skull where the blood vessels enter the brain case. These features of the blood supply to the brain are different from most of the other modern orders of mammals. So this is a unique blood supply pattern, and it's one that we see in many of the other Mongolian mammal skulls that we found.
This expedition to the Gobi has brought back skulls of half a dozen or so mammals with features quite unrelated to modern mammals. This means they are off the main evolutionary track leading to modern mammals. They occur around 80 million years ago. We find the ancestors of true modern mammals, creatures ranging from primates to whales, appearing at about 65 million years. So there is a window of time between 80 and 65 million years ago, during which a rapid diversification of mammals must have taken place.
It's popular to characterize mammals as a great success story that followed from the disasters that befell the dinosaurs. So the mammals took off where the dinosaurs left off. And that's fine as a story, but it doesn't say enough.
Within this time window, mammals survived as the dinosaurs died out. What allowed mammals to diversify and flourish? Here we go back to basic biology. We know that DNA, the genetic material which determines the nature of all living things, mutates and changes. Scientists now can compare the rate of genetic change in different species. In tiny mammals, DNA mutates frequently, leading to a rapid pace of evolution.
Small-bodied animals tend to have very active metabolisms, short lifespans, and very rapid reproductive rates. So we put that picture together, fast gene change and those other factors about the biology of those creatures. That would lead me to think that this explosive radiation was probably the result of the evolution of animals of those kinds of biology.
Small rodent-like mammals benefited from this quick evolution. The more types that evolved, the greater the chance that some would survive beyond the demise of the dinosaurs.
In a sense, the small inherited the earth, and we've for a long time thought that the ancestors of the modern mammal groups were small. But what we're doing is loading that idea with a few more interesting notions about the biology of our ancestors.
The genetic approach is one new tool, but fieldwork remains the key to understanding the history of life on Earth. The search for fossils is the heart of this effort.
The information that one can get from fossils often leads you down some intellectual pathways which you wouldn't really pursue unless you had some hands-on experience of collecting these things. Being out here by yourself also gives you a lot of time to think about some of the theoretical issues and away from telephones and fax machines, that you can come up with some pretty new and different ideas just by being out here.
This is Team Hulsan calling Naran Balak. Malcolm, do you copy? Over. Team Hulsan trying to reach Naran Balak. We're wondering, Team Hulsan is wondering where all our dinner cups are. Malcolm, do you receive? Over. I'm signing off. Over and out. I think the expedition has three fundamental lines of success, and I think it's something that we're very pleased about. Number one, we're beginning to understand the relationships of some of the faunas out here in the Gobi. Assemblages of fossils found in one locality 100 miles from another locality. Another very important thing that we're doing is we're finding some of the fossils we're very interested in. And that includes the dinosaur fossils, the bird-like dinosaur fossils that we're so interested in looking at some of these problems of dinosaur-bird relationships. And we continue to find very important fossils that represent mammals that are of great importance to this question on early mammal origins and evolution. The word life has a strange connotation. It suggests that life is only confined to things that are alive today. But in reality, life on this planet means a whole enormous history that goes back over 3 billion years of living things. So fossils from these rocks are as relevant to those questions about how life exists and changed as things that we see today. And that's very exciting to think that what you find out here in the Gobi Desert has some impact on how you view the relationships of two living creatures. And it can clearly do that.
a production of WGBH Boston. Funding for NOVA is provided by Johnson & Johnson, the signature recognized around the world for commitment to quality healthcare products for the entire family. And Lockheed, America's aerospace company, supporting math, science, and engineering education for national technology leadership. Major funding for NOVA is provided by the Corporation for Public Broadcasting and by annual financial support from viewers like you. Teachers, educational institutions, and organizations can purchase this and many other programs from NOVA's 20th anniversary season for $19.95 plus shipping and handling. To order a video cassette, call 1-800-255-9424.
This is PBS.
Next time on NOVA, join the men and women of the U.S. Aerobatic Team as they perform spins, rolls, and other death-defying stunts. Many of these maneuvers were invented in wartime while trying to escape. Come fly with Daredevils of the Sky. That's next time on NOVA.
For a transcript of the NOVA program you've just seen, send $5 to this address or call 1-303-831-9000.